Suppose A vector, B vector, C vector, and D vector are four distinct non-zero vectors represented by directed line segments from the origin to the points A, B, C, and D, respectively. Show that if B minus A vector equals C vector minus D vector, then the quadrilateral formed by joining the endpoints of these vectors A, B, C, D is a parallelogram. Okay, let's begin. So here we will try to understand the problem first. Let us consider 4 points. We have these 4 points and we're going to name it point A, B, C, and D. And we're also going to consider another point O, and this is going to be the origin. Now we're going to draw directed line segments from the origin to the point O. That means we're going to join point O and point A with the help of a straight line at the arrow going from O towards A. This gives us the vector OA, and this is going to be the vector A vector. So here it's given to us that OA vector, that's going to be represented by the vector A. Similarly, we will be joining point O to point B, and it will be directed towards B. We'll be joining OC with the vector directed towards C, and join OD with the vector pointing towards D. So here we have OB vector. This is represented by the vector B. OC vector will be represented by the vector C, and OD vector will be represented by the vector D. And also it's given to us that B vector minus A vector, that's equals to C vector minus D vector, which implies that what is B vector here? B vector is simply OB vector. So we have OB vector minus A vector. OA vector is OA vector. So OB vector minus OA vector, this will be equals to OC vector minus OD vector. Let's label this as equation number 1. Now let us do a construction. Let's join point A and point B with a directed line segment going from A towards B. So what we'll do, we will consider, now we're going to consider the triangle OAB. So in this triangle, we can apply the triangle law of vector addition to get OA vector added to AB vector. This will be equals to OB vector. So here we have used the triangle law of vector addition. So using the now AB vector, this can be represented as OB vector minus OA vector. Let's label this as number 2. Fine. Now what we'll do, we will join D and point C. So let's join point D and point C with the help of a directed line segment to get DC vector. So what we'll do, we'll consider the triangle in triangle ODC. So here we will consider, again we'll use the triangle of vector addition to get OD vector added to DC vector. So that will be equals to OC vector. Fine. So that means DC vector will be simply equals to OC vector minus OD vector. So this will be equals to let this be equation number 3. Now 2 will be exactly equals to 3 because from 1 we have OB minus OA equals to OC minus OD. So here we can say that the right hand side of both equation 2 and 3 matches. So that means the left hand side must match. That means AB vector will be equals to DC vector. So from 2 and 3 and using equation number 1, we have AB vector equals to DC vector. Now this implies that the opposite sides of a parallelogram are equal and parallel. Hence we can successfully say that ABCD is a parallelogram. Hence proved.